want to be wrong. Okay, guys, so we're going to do a quick lesson here. I've got some data preloaded in Excel, and we're going to learn how to do different types of graphs in Excel, use Excel really quickly, and be able to use some of the functions. So we're just going to start today with some really simple graphing. I'm going to show you guys a couple tricks. But first we're going to talk about data. So you guys can see here that I've got two different sets of data up. And in one case we've got a study done, the effect of shaft material on the speed of an arrow. Here we're dealing with an independent variable, the shaft material. We're comparing apples and oranges, so what kind of change is that? Is it quantitative or qualitative? Any ideas? Are we changing a quantity, or are we changing comparing different things? It's qualitative, right? Yeah, it's qualitative. So we've got a qualitative change. So whenever we've got a qualitative independent variable, we need to use bar graphs. All right, or sometimes in geography, histograms or pie charts, and other things. Sometimes in math they use that, but we're going to use a bar graph, but we're going to use a very specific type. Now we've got all three trials here, so one of the first things that we can do is average our trials. So I'm going to show you guys a quick little trick on averaging. So if you guys have your data written. Okay, so if I ever want to make a formula, I always start with an equal sign, and then that allows me to set up a formula really easily. So what I want to do is add 85, 83, and 82, and I can show you how to do this super quick, and then how to copy this function over so that you know it doesn't waste any more of your time. So I'm going to put a bracket here. I'm going to write the word sum. All right. Now I put a bracket on the outside sum for a reason. You'll see in a second. But I want to add the cells. So B4, and I want to go all the way to D4. Put my bracket on the other side. So right now it's going to find the sum of that. But I want to take that sum and divide it by 3 because there's 3 things I'm adding together. And booyaka, there you go. You get the average of those 3. All right. Now to save time, if I just hit Control-C to copy, and then I highlight the other cells I want to do the same function. If I hit Control-V, boom! There you go. I only had to write one code, and what happens in Excel is it says, oh, you want the same code, but you just want to change the values of it to fit the row that it's in. And so now we have the averages of all of our rows right here. So the 3 trials for wood, the average is 83.33, fiberglass 95, aluminum, or as everyone else in the world pronounces it, aluminium. I've got the average right there. And what we want to do before we start to graph is sometimes averages can be misleading, because sometimes we get data that doesn't fit. So remember, in science we always do a minimum of 3 trials for every condition of our independent variable. Sometimes we like to go for 5 trials. 5 trials is really good, but in this case we have 3. Let's compare our averages to the values that we got. Are there any averages that look a little wonky? Look like they maybe don't fit? Yeah. Okay, so Owen said carbon, the carbon aluminum composite. So what did you notice there? Right, so in this case, the carbon aluminum composite, we had 2 values that were at 75 and 1 value that was at 51. All right? Sometimes we run an experiment and we get these outliers. Sometimes a variable that we didn't realize comes into play, and it causes what we would call an error. All right, and these things happen because there's so many factors in the universe that could come into play. We do our best to control them, but sometimes we have outliers. And what we can choose to do is we can choose to ignore an outlier. So what I could do here in this case is I could take this out and just say, I could take that out and I could say, well, I'm just going to, my two values that were 75 look like they're the right values. So I'm just going to write that there. And I could choose to ignore my 51, my value of 51, but I will need to talk about that later. Now, if I had done this, done 5 trials, and I've got 4 values around 75 and 1 around 51, then that's really good. But I only did 3, and so my confidence in this may not be as strong. We've got our averages here. Let's take a look. 78, 103, 75, 85. So for aluminum, I can see the same thing happening here. I've got 2 values in the mid to high 70s and 1 value that was way higher. I can also here choose to do, I can choose to change things up. So maybe I don't want the sum of all 3 of these. I just want the sum of these 2. And then because it's only 2 values, I'll divide it by 2. And there we go. And so now I get an average that seems to fit the data a little bit better. So I had an outlier of 103 here for the aluminum, and then an outlier of 51. Again, this is up to the scientist to decide what to do. Now I want to graph it. So here's where I'm going to show you a little trick. I'm going to highlight this column because this is going to be my x-axis. It's my independent variable. Independent variables always go on the bottom. They go on the x-axis. I'm going to hit the control button, which allows me to highlight this column. I now have 2 columns that I can choose to use. If I go to insert, I can insert any type of graph that I want. Now, because we're dealing with a qualitative change, not a quantitative change, I'm going to go into the statistical chart, and I'm going to choose a very specific one that works really well for us. And I'm going to choose the clustered column, what you see here. All right, now we could use different colors because that's always nice, or we could choose to have the same color. It's your preference. All right, and so now I've got my chart. One of the things I do want to do is change the elements and make sure I have all the titles, and I can have, yeah, there we go. I can even put a trend line in there, but that doesn't seem to make sense, so I'm not going to put that in. So now I've got a title, a chart title, and my 2 axes titles. And what I can do is I can go in and I can change this up. I can move it around, which I didn't mean to do that. Put that back in the middle. But I can go in here and change my title. So my title always starts with the effect of, in this case, the shaft material on the speed and arrow. And then I'll go in and I'll change my axes titles. So my y-axis is the average speed. Not just the speed, but it's the average speed, and I always put my units in there. And then my x-axis, which is my independent variable, shaft material. Okay, so we're going to pause here and let you guys try this out using the data. Okay, so now we've done a graph with our looking at comparing our changes in our independent variable to the average, but sometimes it's important to look at our trials as well. So I like to split these 2 graphs up into 2 different things. Otherwise, you could potentially put all your trials and the average onto the same graph, but then it gets to be way too busy. So what I'm going to do is I'm going to grab all of this data, and I'm going to make a cluster column again. And what I could do is change up all the different colors to represent the trials. All right, and I'll still need an axis. So I could do something like this, where I've got, but there's only 3 trials here. So this one's throwing in extra information that we don't want. So this is the style that we want. And I'm just going to move this whole thing over a little bit. Okay, so again, really important, I need to put on my axes titles. All right. And then, so this across the bottom is our shaft material. Now, we've got a legend at the bottom that's showing us what the 3 colors mean, trial 1, 2, and 3, which is really nice. And then I want to put my axis title here as well. Now, this is just speed of arrow. All right, and I can grab this and I can move it if I want to straighten it up. And then my chart here will be the same as this. So I can just copy this and paste it right here, just to save some time. There we go. And so now I can do a comparison. I can take a look at what my average, see, on average, did changing the shaft material have an impact? All right, and I can see some materials, maybe carbon, looks like it allowed the arrow to fly faster. That's great. But then really important, I can look at my precision of my results. So how close they were together. All right, so, and I can compare, you know, I can look at my trials here for carbon, aluminum composite and compare that to the average visually. And that's super important. So now that's looking at doing an experiment where you have qualitative changes. I'm just going to really quickly go through an experiment where we had quantitative changes, and we're doing pretty much the exact same thing we did before, but we're looking at quantitative changes. So right now I'm going to start with graphing all my trials against my independent variable. In this case, we're looking at the mass of the arrow on its speed. So I've got my data right here. I'll do the average calculations in a second, but I want to quickly take a look at my data set and see how it's playing out. So I want to again go up to insert, and this time we want to insert a scatter plot. So I believe, oh, maybe it's not that one. There we go. So this is a scatter plot, and I want to see my I want to see my actual lines. And we can do this a few different ways, with the points in it, without the points in it. All right. So we could look at this a whole bunch of different ways. What I probably want to do is not draw my lines and just look at my points. And so what this will allow me to do here is to look at how close my data set is to each other. And again, I'm going to put my titles on for my axes. I can do a trend line if I want. The only problem is with doing a trend line, it's going to connect dots, and it's going to ask you which ones to connect. So I'm not going to do a trend line here. But I'll label in my axes real quick here. So this is going to be the mass of arrow. This is going to be the speed. And I want to grab this as my title at the top. And there we go. What I like about this graph is that it allows me to see how close my data points are, and I can see what the general relationship is. It does look like here that as my mass increases, my speed starts to taper off and go down. Now, when we get into grade 10, I can show you guys some fancy ways to draw lines. Maybe we'll learn about a little bit later. And there are ways that you can put a line on here. But for this, when I'm comparing my averages, or I'm comparing all my trials, I don't need to necessarily put the line on this graph. But I do want to go back and set my average. So again, I'm going to use the sum function. And so B25, and it highlights up, which is nice, so I can see, and then D25, and divide that by 3, and there we go. I get that. I'm going to copy this. I'm going to paste it. Control C copies, Control V paste, and there we go. All right. I can grab my data again, just like we did before, highlight it, hit Control, highlight this, and then I can insert another graph. And this one, I want my points. And we'll take a look at the graph right here. Now, when I take a look at this, I'm going to notice that here I see that there's a nice line sort of developing where all my points are clustered. When I look at my average, it goes kind of wonky. All right? And again, we talked about before in the first part, taking a look at your data and seeing if there's any outliers in there. So if I take a look right here, I could see that this value right here, 26, when I compare it between 81 and 82, it's big time off. So I can go in here and I can say, you know what, I don't want to use this value right here, which is D28. I just want to go to D27. Is that the right one? Or sorry, not D27. C27. There you go. Or 28, I mean. There you go. So those are two values I want to use. And I'm dividing by 2 because there's only 2 values. And look what happens to the line right there. Right away, that little dip there gets fixed up. I can take a look at this, and I can say 99, 133, 98. Wow, that 133 seems a little bit off, so maybe I don't want to use that value. Maybe you do. But if I don't want to use that value, I'm going to correct by putting in the values that I want. So trial 1 was B25, and then I want to add trial 3 and not use trial 2, so that would be D25. There you go. Oh yeah, gotta divide by 2 because there's only 2 values. And there you go. And oh, look at the line now. And we can see that now using the average seems to fit this pattern a lot more. So sometimes it's a good idea. I like to sometimes start with my averages and work back. Or it might make sense to graph all the points first, take a look at where the trends are, then calculate your average and tweak it if you've got outliers that are really skewing the data. If you do an experiment and there's a whole lot of outliers, that probably gives you some insight into how well you controlled variables during the experiment, and it didn't go so well. And then when you go discuss your data, you can't have a lot of confidence in that. All right, but now I've done a comparison of qualitative independent variable using a clustered column graph and a quantitative independent variable using a scatter plot graph.